Okay, here's the question. This one's the annoying type where there are lots of words to read, where it explains that this is all about journey times, and then the question completely ignores that context. So, in fact, the first thing that we really need to pick up on is that we've got a continuous random variable, and the first thing you decide is this the rectangular distribution question, or is it the general CRV question? And you may want to find the other question on the paper to put your mind at rest about which one you're dealing with here. We've got f of t on two particular ranges. We've got to get the expectation of t. That's just direct application of the integration formula on page 11. Set up the integral, put in the limits, do the integration, and you should get this 8/15 out. Then we've got to find the cumulative distribution function f of t, which means the probability of being up to and including each value t. And it's always a good idea, even if they haven't made you to sketch it, is draw a sketch of any old curve if you like, but illustrate what f of t looks like. So always be working with some kind of picture where you can see you've got a t value and f of t is the area up to and including that value. Set up an integral in order to find that area, and the top limit of that integral is going to be t. Integrate as before, substitute in the limits, get an algebraic expression in terms of t, and simplify it if it obviously does simplify, but otherwise leave that as your answer for these 2 marks. Now B part 2 is the interesting bit of this question. We've now got hence, so that means it's going to be useful to have found this cumulative distribution function. Hence find the probability of t being between the mean and the median. And one way of doing this, and it may be the most obvious way, is to start by finding the median, which isn't that difficult because you've got the cumulative distribution function and you should know what you need to make that equal to in order to be the median. But you might find that equation a bit tricky to solve, and it's not necessary, because if you want the probability of being between the mean and the median, this guarantees to me that the mean must be less than the median. So on some kind of sketch, we've got the median there, and we've got the mean somewhere below it, and we're going to need to consider 2 probabilities. The probability of being anything up to and including the median, take away the probability of being anything up to and including the mean. And remember, f of t will give you the probability of being up to and including a known value. So this area, probability of being up to and including the mean, is simply a question of using that value there. But the probability of being up to and including the median is something you can just write down without knowing what the median is, because the definition of the median is precisely in terms of what the probability is of being on either side. So that's a useful shortcut you can do to save you actually working out the median itself.